Now in this chapter polynomials, first let us learn about the definition of polynomial. An algebraic expression in which variables contains only non-negative integral powers is called a polynomial. So for example here, let us take 2x square y cube and z power 5. Here variables are nothing but x, y, z. Three variables we have. All the powers, nothing but powers are here 2, 3, 5. When it is called a polynomial means nothing but these powers should be non-negative integrals. Non-negative integrals. So we know that integers are denoted by z, and this z is nothing but dash dash negative numbers -2, -1, 0, 1, 2, so on like that. But here power should be non-negative integral, means it should not be here -1 or -2 like that. That power should be 1, 2 like that. If power is 0, it is nothing but no variable like that. It is nothing but a constant. So let us suppose 1, 2, 3, 4 like that. All the powers should be positive integers. Nothing but here positive integers. Then only it is called a polynomial. Now here it is nothing but a monomial. Only one term is there. It is nothing but a monomial. Like that sometimes two terms may be there. 3x square 5y cube. Now it is nothing but called a binomial. Here this algebraic expression contains two terms with the variables x and y. Then it is called a binomial. If 3 are there, 3x square plus 5y cube, 7z power 5, then it is nothing but called a trinomial. Like that, a polynomial which contains a single term, then it is called a monomial. Which contains two terms is called a binomial. Three terms trinomial, like that we can say. But here more than one term, nothing but we call it as nothing but a polynomial. Poly means many terms, nothing but a polynomial. Polynomial concept. Next is here degree of polynomial. How to find degree of polynomial? Before finding the degree of polynomial, we must know how to calculate the degree of each monomial of that polynomial. Now, shall I take the example of this 2x square y cube z power 5. Here 2x square y cube z power 5. Here degree of this monomial is nothing but we should add all the degrees of the variables 2 plus 3 plus 5, that is equal to 10. Now 10 is the degree of this monomial. Like that here second example in this 3x square, that degree is 2. Degree of this first monomial is 2 and second is 3 and third is 5. Here we should not add. So in this trinomial polynomial, degree of this total polynomial is nothing but the greatest degree of any monomial. Here three monomials are there. Here greatest degree is 5. Therefore, degree of this 3x square plus 5x cube 5y cube plus 7z power 5, degree is nothing but here 5. Like that, see one more example I give here. 2x square y cube plus 3 y power 3y cube and z power is 5 plus 7, x power is 4 and z power is 6. Now, what is the degree of this total polynomial? To find the degree of this total polynomial, nothing but we have to find the degree of each monomial. So, first monomial is here 2x square y cube. So, degree of this monomial is 5. In the second 3y cube z power 5, degree of this monomial, that is second term, is 5 plus 3, 8. And in third term, 4 and 6 is the 10. So, degree of this polynomial, total polynomial is, which is the greatest degree of any monomial. Here 5, 8, 10. In these three, greatest is 10. So that degree of this total polynomial is equal to 10. In this concept polynomial, next we discuss about the types of polynomials. Based on the degree of the polynomial, we divide it into different types. Then first one is called zero polynomial. First one is called zero polynomial. If the degree of the polynomial is 0, then this is called degree 0 of the polynomial, and nothing but here like constant terms of 2, 5, minus 7, whatever may be. And second is called linear polynomial. Second is called linear polynomial. Linear is nothing but degree 1. If a polynomial which contains degree is 1 is called linear polynomial, and here general form of this linear polynomial is ax plus b. For example, 2x plus 3 or 5x minus 7, whatever may be, it should be in the ax plus b form. Here degree of this variable is 1, so degree of this total polynomial is 1, so that it is called a linear polynomial. And next is called quadratic polynomial. Quadratic polynomial means a polynomial which contains the degree 2. If degree is 2, that polynomial is called quadratic polynomial. General form of quadratic polynomial is ax square plus bx plus c. And next is fourth one, cubic polynomial. That is, degree of the polynomial is 3, then it is called cubic polynomial. General form of this cubic polynomial is ax cube plus bx square plus cx plus d. And next is, fifth one is a biquadratic polynomial. Here biquadratic polynomial means degree should be 4. The general form of this biquadratic polynomial is ax power 4 plus bx cube plus cx square plus dx plus e. About graphical representation of polynomials. Understanding graphical representation of polynomials, I explain about graph system, nothing but coordinate system. Graph on screen. This horizontal line is called x-axis and vertical line is called y-axis. Intersecting point of these two axes is called origin, which is denoted by O, and the coordinates of this origin 0, 0. X coordinate is 0, y coordinate is also 0. In this side, x-axis is positive 1, 2, 3, 4, 5, and this is called x-dash axis, and it is negative minus 1, minus 2, minus 3, minus 4, so on like that. And this is called positive y-axis, and 1, 2, 3, 4, 5, 6 like this. This is y dash is called negative y-axis. Now we can represent these points by coordinates of x and y axis, like if x is equal to 2, 3, for example, on x axis we supposed to take 2 and on y axis supposed to take 3. Where these two intersects is nothing but called 2, 3 point. 2, 3 point. This point is called 2, 3 like that. The same way we can represent all the points of these four quadrants. This is Q1, Q2, Q3, Q4. Four quadrants also. In first quadrant both are positive. In second quadrant x is negative, y is positive. In third quadrant both are negative, x is negative, y also negative. And in fourth quadrant x is positive and y is negative. Like that we can plot the points in this coordinate. Here x equal to k is represents a straight line which is parallel to y-axis. For example, if x is equal to 2, that is all the y coordinates are 0, x coordinate is 2, here 1, 2, 3, 4, 5, 6, like that. If you take all these x coordinates nothing but 2, so that we will get a straight line which is parallel to y-axis and 2 units distance from it. In the same way, y is equal to k is parallel to x-axis and it is k units distance from x-axis. For example, if you take y is equal to some 3. So, here 1, 2, 3. This line passes through this 3 point and which is parallel to nothing but x-axis. This is called y is equal to 3. Y is equal to 7 is given, then it passes through this point 7 which is parallel to x-axis like this. Now let us see how to represent a polynomial. See, polynomial is denoted by p of x is equal to, let us suppose some 2x plus 3. That is, p of x is nothing but y, then it is y is equal to 2x plus 3. So, we have to draw a straight line of this y is equal to 2x plus 3. So that we have to get some x and y coordinates according to this given value of 2x plus 3. So that at least here 2 points are required. More than 2 points means we can draw a straight line very easily. So in this, let us take some x values negative as well as 0 as well as some positive values for x. Let us suppose if x is minus 1, how much you will get? You substitute in that 2 into minus 1 plus 3. That is equal to minus 2 plus 3. 3 minus 2 is 1, so it is plus 1. Let us substitute x equal to 0. Substitute in that 2 into 0 is 0, it is 3. Let us substitute 1 now. 2 1 is 2 plus 3 is 5. Now plot these points minus 1 1 as well as 0 3 1 5 in this coordinate system. Minus 1 on x-axis, minus 1 here and plus 1 is here y-axis. This is a point. And then 0 3 on x-axis 0, y-axis 3 0 3 and 1 and 5 on x-axis 1, y-axis 5. Now add these 3 points with the scale and we can extend the line also. This is straight line which is called y is equal to 2x plus 3. Now for this straight line we can find now 0 of this polynomial p of x is equal to x plus 3. That is, for this 2x plus 3 polynomial, 0 is x coordinate. Where it cuts the x-axis is called its 0 of the polynomial. So here x-axis it cuts at here minus 1 and minus 2. Between minus and minus 1 and minus 2, that is minus 1.5. Now we can check our answer. Already we know that we have to equate this given polynomial with 0. 2x plus 3 equal to 0. That is 2x equal to minus 3. X is equal to minus 3 by 2. That is minus 1.5. So zeros we can find by using this graph system also in this way. By drawing that given polynomial, it may be not always a straight line. Sometimes it may be nothing but a curve or a parabola also. When we will get, see here, whenever it is some y is equal to k, we will get a straight line which is parallel to x-axis. Nothing but it is a constant. It is nothing but a constant. And next is whenever we will get like this, in the form of mx plus c, y is equal to mx plus c form, then it is nothing but straight line we will get, and is nothing but called, why we will get straight line is nothing but, it is a linear polynomial. Every linear polynomial represents a straight line on graph system. Here, this linear polynomial, nothing but degree 1, it is called linear polynomial. Already you have learned in types of polynomial. So, linear polynomial represents a straight line. As well as next is quadratic polynomial. What is the general form of quadratic polynomial? That is ax square plus bx plus c is called the general form of quadratic polynomial. For example, 2x square plus 5x plus 3, 7, whatever maybe you can take. And let this is p of x, nothing but we call it as y is equal to something. And whenever it is a quadratic polynomial, we get a parabolic shape like this. This is called parabolic shape. Sometimes like this maybe. So this parabolic shape is curves intersects the x-axis in 2 points, so that this quadratic polynomial will have 2 zeros. So every quadratic polynomial will have 2 zeros like that, and it will have the shape of this parabola. Okay, we have cubic polynomials as well as biquadratic polynomials also. Now these cubic polynomials, nothing but we will get a curves like this, and for this biquadratic also we will get two parabolic shapes we will get, and as well as this cubic polynomial will have 3 zeros, whereas biquadratic polynomial will have 4 zeros. But you learn more about these cubic and biquadratic polynomials, how to represent them in graph system in higher classes. Okay. Now, for us only this linear polynomial and this quadratic polynomial representation is enough. Conclusion is, we can represent this 2x plus 3 like mx plus c, p of x is equal to ax plus b. General form of linear polynomial is p of x is equal to ax plus b. This ax plus b polynomial represents a straight line. So, in how many places or where it curves the x-axis, that x value is nothing but 0 of that linear polynomial. Whereas this quadratic polynomial p of x is equal to ax square plus bx plus c is parabolic shape we will get. In two places it cuts it intersects the x-axis. That values, x values, nothing but called zeros of this quadratic polynomial. So, linear polynomial will have 1, 0, whereas quadratic polynomial will have 2 zeros, and cubic 3 and biquadratic are 4 zeros. Now, let us see some examples from your textbook. This graph, you can observe that these parabolas not intersecting at any x point. So, it is not intersecting x-axis. Here in second also, there is no intersection with the x-axis. So, in these cases, we say that these polynomials do not have any zeros, no zeros of the polynomials. Case 1, we can observe that these parabolas, nothing but polynomial graphs, intersecting x-axis in 2 points, a and a dash. In this also same a dash and a. Here these polynomials intersecting x-axis 2 points, so that we call nothing but these two polynomials have 2 zeros. Here, this case 2, we can observe that these parabolas intersecting x-axis at a single point A in this case 2, so that it will have only a single zero, only 1 zero of this polynomial. Now, example 1 from your textbook, here 6 graphs are given of polynomials, different polynomials. We are supposed to write the number of zeros that polynomials will have. Now you observe this first bit. Here it intersecting x-axis at only one point, a single point, so that in first bit this polynomial have only 1 zero. Now you observe this second bit. Here it is parabolic shape as well as intersecting x-axis at 2 points, so that polynomial represented by this graph will have 2 zeros, because this graph intersecting x-axis at 2 points. Now let us take this third bit. Here 1, 2, 3. This given graph intersecting x-axis at 3 points, so that the polynomial denoted by this graph will have three zeros. As well as if you take this fourth bit, here in x-axis, we have to observe only x-axis, it intersecting at only one point, single point, so that this polynomial which is representing by this graph will have only 1 0. As well as here also this intersecting at only one point, this x-axis, so that polynomial represented by this graph will have only 1 0. As well as here, if you take this fourth bit, 1, 2, 3, 4. This graph intersecting x-axis at 4 points, so that polynomial represented by this graph will have 4 zeros. Now, welcome to my channel Math. In this polynomial chapter, today we learn about relationship between zeros and coefficients of a polynomial. The general form of a linear polynomial is ax plus b. So let p of x is ax plus b. That is, let p of x is equal to 0. So that implies now ax plus b is equal to 0. That implies ax is equal to on that side minus b, x is equal to minus b by a. Then this minus b by a is called 0 of this polynomial. So we know that for a linear polynomial there is only one 0. So 0 of this polynomial ax plus b is minus b by a. Is zeros of a quadratic polynomial. Zeros of a quadratic polynomial. We know that general form of a quadratic polynomial is ax square plus bx plus c. So here it is a quadratic polynomial. We will get two zeros for this quadratic polynomial. One example for quadratic polynomial, x square minus 5x plus 6. So let p of x is equal to x square minus 5x plus 6. So that to find zeros of this quadratic polynomial, we suppose this p of x is equal to 0, then x square minus 5x plus 6 equal to 0. So we can factorize it, x square minus 5x plus 6, that is 6 ones are 6. For 6 factors are 3 into 2, 6. And if we add that 3 and 2 with minus 3 minus 2 is equal to minus 5. So here minus 3 into minus 2 is minus 6. So summation of this minus 3 and minus 2 is minus 5. So we can split this middle term minus 5x as minus 3x and minus 2x. So that implies x square minus 3x minus 2x plus 6 is equal to 0. Now we can take x common, left is x minus 3 minus 2 common, x plus by minus is minus 3 equal to 0. In these two terms x minus 3 is common, so that x minus 3 into x minus 2 is equal to 0. So from this we will get x is equal to 2 or 3. So these 2 and 3 are called the zeros of this x square minus 5x plus 6 equal to 2 zeros, 2 and 3. Sum of these two zeros, sum of zeros equal to 2 plus 3, that is equal to 5. Product of these two zeros, product of two zeros, 2 into 3 is equal to 6. Now let us compare this x square minus 5x plus 6 equal to 0 with our general form ax square plus bx plus c equal to 0. Then in place of a it is 1, in place of b it is minus 5, in place of c it is 6. So here sum of zeros there is a formula for it. Sum of zeros is equal minus b by a. That is equal to minus of, what is b? B is nothing but coefficient of x. Coefficient of x by coefficient of a means coefficient of x square. That is coefficient of x square is a, then coefficient of x is b minus b by a. So here you substitute this one, minus b by a is how much? Minus of minus 5 by 1 is equal to 5. So these we got the same here. Sum of zeros 5. In this also 2 plus 3 is equal to 5. 2 plus 3 is equal to 5. The product of zeros formula is c by a. Here c is 6, that is equal to 6 by 1 is equal to 6. At the same time we also got that 2 into 3 is 6. Let alpha and beta are the zeros of given polynomial ax square, which is in the form of ax square plus bx plus c. Then alpha plus beta, sum of the zeros alpha plus beta is equal to minus b by a, and alpha into beta, that product alpha into beta is equal to c by a. Sometimes they give zeros of any polynomial like alpha and beta if zeros of any polynomial given, zeros of any polynomial or alpha and beta, then we can write that polynomial p of x is equal x square minus x into sum of the zeros alpha plus beta plus product of the zeros alpha into beta. Like this, if any zeros of polynomial is given, we can prepare polynomial for that. In that above example, we can use, that is alpha is equal to 2, beta is equal to 3. Then you substitute in that p of x is equal x square minus x into alpha plus beta is 2 plus 3 plus alpha into beta is 2 into 3. That is x square minus 2 plus 3 is 5 minus 5x plus 2 3 is 6. This is the polynomial, quadratic polynomial, which is having the zeros 2 and 3. With one more example, let us suppose zeros of polynomial alpha is equal to some 3 and beta is equal to 5. How to prepare quadratic polynomial which is having zeros of these 3 and 5? We know that formula p of x is equal to x square minus x alpha plus beta alpha into beta. That is p of x is equal x square minus x and sum of the roots 3 plus 5 plus product of roots 3 into 5. Then it is x square minus 3 plus 5 is 8 minus 8x plus 3 5 is 50. This is a quadratic polynomial which is having the zeros as 3 and 5. Now let us do problem from exercise 2.2. In that first question is find the zero. Now in this polynomials chapter, next concept is a division algorithm. That is division of a polynomial with another polynomial. For learning about this division of a polynomial with another polynomial, let us discuss about the division rule. Division rule of our arithmetic. What is meant by division rule? You know about the division. Let us suppose a number 28. Let us divide with 3. We know that it is 3 8s 24. Now left is 4 is the remainder. Here dividend is equal 28 and divisor is 3 and quotient here is equal to 8 and remainder is equal to 4. According to division rule, here division rule is nothing but dividend is equal divisor into quotient plus remainder or. Let us substitute the values here. Dividend is 28, divisor is 3, quotient we got is 8 plus remainder is 4, that is 3 8s are 24 plus 4, that is 28 is equal. 28 is equal 28, this 24 plus 4 is 28, hence the division rule is verified. Hence division rule is verified. Of polynomials, let P of x is your dividend and g of x is divisor and q of x is quotient and r of x is remainder. Then according to division algorithm, now dividend is equal divisor into quotient plus remainder. So here dividend is P of x. So P of x is equal divisor is g of x into quotient is q of x plus r. E is called the division algorithm. In division algorithm of polynomials with one example from your textbook, that is divide 2x square plus 3x plus 1 by x plus 2. Here P of x is equal to 2x square plus 3x plus 1 and g of x is equal to x plus 2. Then after doing division we will get here q of x, that is quotient, as well as r of x remainder. So we consider this P of x 2x square plus 3x plus 1 and divide with this x plus 2. Now to get the first term of the quotient, let us consider the first term of the dividend including symbol, here both are plus 2x square, by the first term of the divisor, that is x. Now this x and x square gets cancelled, so whatever left is nothing but equal to 2x. This 2x is the first term of the quotient, that is 2x. Now multiply these two terms of the divisor with the term 2x. 2x into x is 2x square plus 2 into 2 4x. Now you subtract this. While subtracting you change the symbol. This plus becomes minus, plus becomes minus. Here 2x square minus 2x square. First term always gets cancelled. And here plus 3x minus 4x. 4 is greater. Its symbol is minus. So here we get minus x and plus 1 as t is. Again to get the next term of the quotient, first term of the dividend by the first term of the divisor minus x by x. So xx gets cancelled, this minus 1. Now minus 1 is the second term of the quotient. Now again you multiply this x plus 2 with this minus 1. Minus 1 into x is minus x, plus into minus is minus 1. 2 into minus 1 is minus 2. Now it is subtract, the symbols changes, minus becomes plus, this minus becomes plus. Now minus x plus x gets cancelled, plus 1 plus 2 is 3, which is nothing but a remainder r. Here this 2x minus 1 is for the quotient, nothing but this is q of x and this is r of x. Now let us check, verify this division algorithm, nothing but the division rule of these polynomials. Here p of x should be equal to g of x into q of x. Anyone you can write first in these two, no problem, plus r of x. Now here p of x is given 2x square plus 3x plus 1 is equal to, here this side is x plus 2 into 2x minus 1 plus 3. Now multiply these two binomials, 2x into x is 2x square plus 2x into 2x is 2 to the 4x. Now with minus 1, minus 1 into x is minus x, minus into plus is minus 1 to the 2 plus 3. Now that is equal to 2x square, 4x minus x is plus 3x, 3 minus 2 is 1 plus 1. So this side also same p of x we have through 2x square plus 3x plus 1, both are equal, so that this division algorithm is verified, hence verified. Hence verified this division algorithm. Now let us do one more example from your textbook. Before that, I explain here what are the important points you have to consider while writing this p of x as well as this g of x. P of x and g of x both should be in descending order of their degrees of that variables. For example, if p of x is given like this, let us suppose x cube minus 2x power 5 plus 3x square minus 2 plus 7x. Here given polynomial p of x is not in descending order of the degrees of the monomials, 3, 5, 2 and here 0 and 1 like that degrees. So we have to write here they are in descending order of their powers, you can say nothing but degrees. So what we do is first we take that minus 2x power 5. Next 4th term is not there. If any term is not given in the middle, you always keep 0 in that place, nothing but 0 into x to the power of 4 like. And then after that x cube term, x cube. Next is plus 3x square plus 7x minus 2. Like this, p of x or g of x both should be in descending order of their powers of variables. Now another example from your textbook, divide 3x cube plus x square plus 2x plus 5 by 1 plus 2x plus x square. That is here p of x is equal to, let us write in order, same it is there in descending order, so change, no need to change it, 3x cube plus x square plus 2x plus 5. Now let us write this g of x, nothing but divisor. It is not in the descending order, so we will write like this, x square plus 2x plus 1. Now let us do this division, 3x cube plus x square plus 2x plus 5. Now divide with x square plus 2x plus 1. Now first term by first term. Here in dividend, first term is 3x cube. Now in first term divisor is x square. This x square cube gets cancelled, left is 3x. This 3x is the first term of quotient, that is 3x. Now multiply this x square plus 2x plus 1 with this 3x. 3x into x square is 3x cube. 2 into 3x. 2x into 3x is 2 3 is 6. X into x is x square plus 1 into 3x. Now we have to do the subtraction. While subtracting, that symbol changes. This plus becomes minus, plus becomes minus, plus changes into minus. First term gets cancelled. 3x cube minus 3x cube. Now it is minus 6x square plus x square is, we will get minus 5x square. Plus 2x minus 3x is minus x, and then plus 5 is same. Again first term is minus 5x square by first term of the divisor is x square. X square gets cancelled, we will get here minus 5. So multiply this x square plus 2x plus 1 with minus 5. Minus 5 into x square is minus 5x square. So here minus 5 into plus is minus 5 to the 10x. Minus into plus is minus 5 ones are 5. So you subtract this, minus becomes plus, minus becomes plus, minus becomes plus. This minus 5x square plus 5x square gets cancelled. Minus x 10x is 10x minus x is 9x, and plus 5 is plus 10. Here 9x plus 10 is the remainder, nothing but called r of x. So here what we got, quotient is q of x. Q of x is equal 3x minus 5, and r of x remainder is 9x plus 10. Where we have to stop this division is here, the degree of this remainder 9x, that is 1, should be less than the degree of this divisor. Here x square is there. When we get like this, a polynomial which is having the degree less than the divisor, then we can stop. Now we can check this division algorithm using this px, g of x as well as this q of x and r of x. Into division, let us verify division algorithm for this. We know that according to division algorithm, p of x is equal to q of x into g of x plus r of x. Here p of x is 3x cube and plus x square plus 2x plus 5, that is equal. Q of x is, so we got 3x minus 5, and g of x is given that x square plus 2x plus 1. Remainder we got 9x plus 10. Now we multiply these two terms, 3x minus 5 with x square plus 2x plus 1. We will get 3x cube minus 5x square plus 6x square minus 10x plus 3x minus 5. As it is plus 9x plus 10. Now let us simplify this. 3x cube we will get as it is minus 5x square plus 6x square. Plus is greater, it's 6. 6 minus 5 is 1, that is x square. Minus 10x, here plus 3x is there. So it is minus 10, here plus 3x plus 9x, that is 12. 12 minus 10 is 2, 2x. And here plus 10 is there. And here minus 5. 10 minus 5 is plus 5. So this side also we have same, that is 3x cube plus x square plus 2x plus 5. So both we got that p of x is equal to q of x into g of x plus r of x. Hence that division algorithm is verified. Thank you for watching my video. Like it and share it to your friends. Subscribe my channel